First of all, I'd like you to change the title of this section from solving trig equations graphically to solving trig equations, the general solution. And we are going to just start with some warm-up questions for solving for theta. So this is really getting you to go through the process of how do I solve for an angle, how do I find my reference angle, how do I then find out my answer, and here the domain is given from 0 to 2 pi. So now you've had a little bit of time to look at this one. I'm going to go over this one a little bit faster in case you're stuck. What do you want to do? You first of all want to get sine inverse by itself. So we divide both sides by 3. Now to get our reference angle is always found by doing the inverse of the positive value. This is a very important thing because if you do sine inverse of the negative value or cos inverse of the negative value, you'll get an answer that isn't in quadrant 1. And a reference angle is always an angle between 0 and 90 degrees. So when finding our reference angle, we always do our inverse of the positive value. Sometimes people even draw the pictures of the triangles. Okay? For this function, sine is negative. Sine is negative in quadrant 3. So you could draw an angle in standard position in quadrant 3 or quadrant 4. And notice every time that we draw our triangle, we always draw it back to the nearest x-axis so we can label our reference angle. In this case, sine opposite over hypotenuse. This is where the 2 and this is where the 3 is. So you could use your picture to do your normal SOHCAHTOA to find your angle. We find our angle to be 0.73. Then if you want to find it in quadrant 3, you would have to go pi plus your reference angle. And in quadrant 4, it would be 2 pi all the way around minus your reference angle. So there's your first one. We did that one together. Here's the second one for you to try. As you get better at them, you don't necessarily need to draw the triangles. But find your reference angle, figure out what quadrants it's in, and then solve from there. Again, we're still thinking in radians. Get tan by itself, you get -3/8. Find your reference angle by doing tan inverse of +3/8. You get 0.359. And then where are our answers? Tan is negative in quadrant 2 and quadrant 4. So there are our answers. Now, these first two ones would have been calculator questions because you would have had to find your reference angle using your calculator. These next two questions that I'm going to get you to do are non-calculator. So now anytime you're getting a solving question that's non-calculator, it means that that value you should know, probably from your pie plate. And that's the reason that we do this as part of, before we do our Chapter 6 test, because these questions are going to be asked on your Chapter 6 test as well as on your Chapter 7 test. So in C here, when you solve for cos, you get cos theta equals 4, which isn't on your unit circle, but that's not possible. Because if you tried to draw the triangle, you would have 4 over 1 adjacent over hypotenuse. You have an adjacent side of 4 and a hypotenuse of 1. You just can't draw that triangle. So anytime sine or cos has a value bigger than 1, it can be done without your calculator because you know that it's not possible. For part D here, again, getting tan by itself, you get -1 over √3. Now, you might not recognize this on your pie plate because of the way that it's written, but if you would rationalize that denominator by multiplying top and bottom by √3 over 3, then you find out that this is equal to -√3 over 3, which is on our pie plate. That's part of our pi over 6 family for tan. And you would get those two as your answer. We're going to do one more example. This one is going to be calculator again. on your formula sheet, they give you the quadratic formula. So that was something you learned last year, that negative b plus or minus b squared minus plus or minus square root of b squared minus 4ac over 2a. I'll write it up again. The reason they give you that is they're going to ask questions that are quadratic. So this is a quadratic equation with sine, cos, or tan. This one has tan. That normally we've done some like this before, but we were able to factor them. But if you're given a question like this one and you can't factor it, then you're going to need to use the quadratic formula. So we haven't done any questions so far that needed the quadratic formula, so I'd like to show you one now. Now, this formula, I'll put it in a green box here, this formula is for when you have ax squared plus bx plus c equals 0. So what's the difference right now that we have compared to the formula? Well, we don't have x. So we won't be writing x equals, we'll be writing what? Tan equals. Can you see that we have a tan instead of an x? It's the tan that's getting squared. And then a tan here as well. So you will start by saying, well, I know it's going to be tan theta equals. Your b value is what's in front of the x, your a value in front of the x squared. So for us, our b value will be what's in front of the tan theta, plus or minus the square root of negative 3 squared minus 4. Our a value is 1. Our c value is negative 7, all over 2 times a. And what we get when we simplify this is we get negative 3 plus or minus, this is going to be 9 plus 28, positive 37 over 2. What that means when we go to type that into our calculator, and again, if you're not using this often yet, I would like you to, so on our calculator, if you have the option to write things as a fraction, alpha y equals brings this menu up, the very first one, allows you to write things as a fraction. This is going to be really nice. So we have negative 3, and I'll do the positive one first, plus the square root of 37 over 2 is one of our answers. So we know that tan theta is 1.54. And I'm just going to go dot, dot, dot to say that I'm not going to lose any of those decimal places when I'm figuring this out. So if I'm using this value, tan is positive, it's going to be in quadrant 1 or quadrant 3. I now need to figure out my reference angle, so I can go tan inverse, and I can either go answer like this, or if your calculator is new enough, you can actually use your arrow keys and highlight the number from above, and it will retype it in a lot faster than having to retype in everything yourself. Pushing enter, we find out our reference angle is 0.995. So that means in quadrant 1, it's going to be the same. In quadrant 3, where tan is also positive, I can go pi plus my reference angle, which I have right here, so I can just highlight and push enter. And we have 4.14. That's when we use the positive value. We found our two answers. Right? Our fraction could also be negative 3 minus the square root of 37. So I go back to my calculator. I could retype it in, or I can go up to it, highlight it, push enter again. It will retype it for me. And then I can just go to that plus sign and change it to a subtract sign instead. And now I get tan of theta equals negative 4.54. going to put dots there to say I'm going to keep all my decimal places. If you round an answer early, it could mean that your answer that you get in the end is also off by a few numbers. And when they're checking the accuracy of your results, they're always looking at your final answer. So now I want to find my reference angle, and I want to go tan inverse of this number, but when we're finding our reference angle, we always do the tan inverse or sine inverse or cos inverse of the positive value. So I'm going to go back to that negative there, take that out, and I find out my reference angle is 1.35. Now sometimes, I've been using my answer from before, where I've been highlighting it and putting it in, and that's fine. But if you have an older calculator, you can't use the arrow key to go up to something. Another really useful thing for using an answer over and over again is above your on button is a store button. So what I'm going to do is I'm going to hit the store button, and it says, where would you like to store your answer? And you can choose any letter that they have. So you can go alpha A, alpha B, and you could pick a letter, or you can just hit the X button and store it as X. And storing something as X doesn't affect graphing or anything else later. It just allows you to use that in this screen. And as soon as you store something over top of it, then X changes to a different number. So here, tan is negative. I know that tan is negative in quadrant 2, so I'm going to go pi minus my reference angle. And since I've stored it as X, I can just go pi minus X. And I figure out one answer is 1.79. And the reason it was nice to store it as X, because we also have to figure it out in quadrant 4. In quadrant 4, you'd go all the way around 2 pi minus your reference angle, and you get 4.93. So what we've done here is we are able to use our quadratic formula to get what tan theta was equal to. And there's going to be two answers, because in the quadratic formula there's a plus and a minus. But then everything else is the same. You still need to find your reference angle. You still need to say which quadrant it's in, so you can solve it from there. So this is just a little bit of review of the quadratic formula, reference angles, and solving for angles. Today's lesson is about the general solution. So now we're going to talk about that a bit.